Hi everyone, I am Bihan Chakraborty and today I'll be discussing the problem number 733 flood fill. So just go through the problem once if you haven't. So what's stated in this problem is that we have to implement a flood fill algorithm. So let me explain it in MS Paint. This is the same algorithm that's used to implement the fill with color tool. Okay, so let me just draw two lines. I've zoomed so you can see it. Okay, yeah, this is one, and let me draw another orange through here. Okay, so what's said in the problem is that we have been given an image where each cell represents a pixel, and we have been given a starting row and column point. So this like we have been given a cell and we have to dip and we have been given a new color. So what we need to do is uh, flood all the cells that's connected to this cell through vertically and horizontally and fill all of them with new color. So let's just see the problem. We are starting with 1, we have the new color is 2, so we have to make all the cells that's connected to this 1 cell 2, and that's not connected diagonally. So this is vertically connected, so we make this 2. With this, these and this are connected, so these also become 2, and similarly these two also become 2. But this one at the last, it never becomes 2 because it's not connected to any of the ones vertically or horizontally. So that is the problem. So let's check here. Suppose this is the situation, and if I click here, only this line becomes red, only this rectangle. These whites and greens doesn't become red. So what we need to check here, that whichever pixel I click on, all the pixels related to it that are of the same color as that given pixel should only become red, right? If I select the green, okay, for some reason there might be some gap here. If I click here, yeah, so as you can see, if I click here, everything becomes red because these all are green. This, if I select here, all the cells that are white only becomes red. So this is the flood fill algorithm. So let me start. The way we can do this is using BFS or DFS. So I'll be using DFS here. Okay, so let me write a private function, private void DFS. We don't need to return anything through here because we have to return the whole image in the problem, and we can modify the original image. So I and j would be the current cell we are on. So now we need the image, of course, and we need the new color and old color as well, because we need to check. First of all, let's check all the bounds. So I less than 0, less than 0. So if it's out of bounds, then we will return. Now we need to check two other conditions. First of all, we have to check whether the current cell is of the old color or not. So image of I of j not equals to old color, then we return, because suppose we are at 1 and we move at this side, and this is not old color, this is a complete different color and we are not interested in it. So if we move here, since we will be ignoring them, we will return simply. So we return. Now another condition we need to check is that whether the new color is the same as the old color. So if new color, then we return as well, because suppose here I'm selecting green and then clicking here, nothing should happen, right? So that condition is this one. So after all the base cases are handled, now we will replace the image cell with the new color, image of ij equals to new color Now this is done. So starting from here, this one becomes 2. Now we need to move to all the cells adjacent to it vertically and horizontally, and do these 4 steps on them as well. So we can run the DFS. I am not discussing the DFS from scratch. I hope you are familiar with it. So I plus 1 j, that means we are going below, then old color, yeah. So the last 3 arguments would be the same, only the coordinates would change. So I plus 1, I minus 1, that is upwards, this is right, and this is left. So up, down, right and left, yeah. So let me call it here. DFS starting from SR and SC. Old color would be the color of the SR-SC cell. And we return the image, of course. So one thing to note is that I haven't used a visited array in the DFS, and the reason is this condition. This condition takes care of the visited. Suppose I am at 1, I make it 2, we move here. So next time I won't ever be coming to 1 again, because it has already become 2 and it is not same as old color. So this condition will always be false for this starting coordinate, like that. So we make it 2, we move here, we make it 2, we go here, we make it 2, then come back, then go here, 2, 2, 2, then we return back, we check these ones as well, and we return from here, because this condition fails. This condition fails, and as this condition fails for zeros, this will also fail for 2's. So that is why we don't need a visited array again. So the time complexity of this problem is O of n. As DFS, we are using DFS, and space complexity, as you can see, is O of 1 here, but since we are using recursion, so the stack tree will take O of n's space as well. So let me run it. Okay, yeah. Yeah, so it's submitted. So if you have any doubts on this problem, please comment below, and if you have liked it, please like the video and subscribe to my channel. Thank you.